Hi all. See this in this particular problem we are having two functions, right? F and G, right? And it is defined directly, right? And say that we have to find the area bounded by this two curve in the first quadrant. So we don't bother about anything what happened x less than 0, y less than 0 and all that. Always x greater than 0, y greater than 0. So let's see that what is our function. So let's come back with the function fx, right? See that fx includes the mod function. So obviously we have to use the definition of mod function. So let's write down that. So my function fx is equal to e to the power of x minus 1 minus e to the power of minus of mod of x minus 1. That's it. So that's imply that the function fx will be become e to the power x minus 1 minus e to the power of minus of 1 minus x when x is less than 1. And it's became e to the power x minus 1 minus e to the power of that x minus 1. So therefore it will be 1 minus x when x is greater than equal to 1. Okay, that's it. What's the definition we use here? We use the definition of mod x minus 1 will be equal to x minus 1, right? I just wrote that here, but that here we use the definition that mod of x minus 1 is equal to x minus 1 when x is greater than equal to 1 and is equal to 1 minus x when x is less than 1. So if I use this definition, right, that will come, right? So therefore we can easily write down what is the function fx, right? So therefore my function fx will be simplified as this is 0, right? See that it is having the same function. So it is 0 and we have it as e to the power x minus 1 minus e to the power 1 minus x when x is greater than equal to 1 and when x is less than 1. So that is the function fx. Now the function gx, let us consider that to the function gx is equal to 1 by 2. The same function of addition. So e to the power x minus 1 plus e to the power 1 minus x. And this is happened all over that interval, right? That's it. So we are able to rewrite and understand that what is the function using the definition of mod x minus 1. So this is actually very easy. Okay. Now we have to understand that area bounded by the region. So let's understand that how the plots can be, right? That's first we have to understand, right? Let's see that the plot of fx will be something like that. It is 0, right? So from 0 to 1, the function is 0. And then it will increase somehow, right? Because it's e to the power x minus 1 and so d dx is greater than 0. So it will be in increasing function and all. So therefore it will increase, right? If I talk about gx, right? So gx will be higher or lesser. That we have to understand that, right? Now see that if I substitute x equal to 0, what will happen? If I substitute x equal to 0, this gives e to the power minus 1 plus e. So it is giving you some value, positive values. So therefore the function will start with some higher and it goes on, right? So that will be the plot, right? Now to find out that in that limit of is x equal to 0 and the point of intersection, right? It is always right. Our function is greater than, right, the fx function, right? So we can say that entirely, right, the function fx is greater than equal to gx is greater than equal to fx entirely. So we'll say that in first quadrant fx is less than gx. We can say equal to because there is a possibility that they will intersect. So obviously we need to find the point of intersection. So point of intersection between the curve fx and gx. Now obviously that x equal to 0, they will not intersect, right? They will intersect only for the e to the power x minus 1 definition. That means x greater than 1, right? This is 0, this is 1 and I have to find out this value. Then only we are able to integrate it, right? So that's the concept, right? So let's go ahead and find this point of intersection. So therefore we'll say that for point of intersection of fx and gx for x greater than equal to 1 region. Let's equate these two definitions. So therefore it says that e to the power x minus 1 minus e to the power 1 minus x, that's equal to 1 by 2 e to the power x minus 1 plus e to the power 1 minus x. Now let's go ahead and solve that. So therefore if we rewrite that and take it in one side, we'll get it as 1 by 2 e to the power x minus 1 is equal to 3 by 2 e to the power 1 by x. Just take all the terms together. So therefore it's imply that e to the power x minus 1 divided by 1 minus x, so therefore minus 1 plus x is equal to 3. That's imply that e to the power 2x minus 2 is equal to 3. If I take the log both sides, so we'll get it as 2x minus 3, 2 is equal to log of 3. And therefore, x is equal to 1 plus 1 by 2 log 3. Or in other way, we can say that it's 1 plus log of root 3. So that's the point of intersection. So therefore this line, okay, will come back as 1 plus ln plus root 3. So therefore you have to find the shaded region. How to find the shaded region? This is the shaded region we are having, right? That's it. So how we find that? See that the function fx changes definition, right? This function is all about fx and this is gx, okay? So the function changes definition. So therefore we need to separate that. So we have to separate based on that x is equal to one line. So 0 to 1 gx dx, and we can say that then it is gx minus fx. So that's our problem, right? So let's see that whatever we are trying to explain with our sketch, is it happen really, right? Because we see the other videos as well. We always show you the exact plot. So this is the exact plot for this function, right? Now see that here we already find out all those information. So let's put it here. So this is actually x is equal to 1 plus ln of root 3. This is x is equal to 1. This is actually 0 function. This is actually the non-zero function of fx actually. So I just wrote fx here. Okay. This is gx. So now we see that we need to find out the area. So therefore we can say that the required area is equal to 0 to 1 gx dx plus 1 to 1 plus ln root 3. Fx gx minus fx. That's it. So therefore, by this option, we'll get that this is 1 plus ln root 3. You'll have to write out again, okay? So that's why we'll get that area 1 and area 2. So now our job is to integrate it separately, right? So let's go ahead. So we know that when I write fx and gx, we'll use these two definition. So let's go ahead. So therefore, we'll say that it is equal to 1 by 2 integration of 0 to 1 gx equal to e to the power x minus 1 plus e to the power 1 minus x dx plus integration of 1 to 1 plus ln root 3 function of gx. So this one minus this function. So let's write down it together. So if I subtract, we'll get it as 1 by 2 x minus 1 minus x, so minus and plus. Okay. So therefore we can write it as 3 by 2 e to the power 1 minus x minus 1 by 2 e to the power x minus 1 dx. Just subtract that to function and we'll get it done. So see that here, basically what we performed here, gx. So e to the power x minus 1 and it minus of that. So it will gives you minus 1 by 2. So I just wrote it. It is became 1 by 2 plus e to the power 1 minus x. So that gives me the 3 by 2x. So everything is an integration. Now here we can use substitution because it is a x minus n and all that stuff. But we don't use substitution. We can directly do that. Why? Because if I integrate the e to the power x minus 1, what will happen? Integration of e to the power x minus 1 will gives you the e to the power x. Okay. If I assume that z equal to e to the x minus 1, so it's e to the power z, right? So e to the power z dz, and dz and dx are equal. So therefore we can directly write it as straightly as 1 by 2 e to the power x minus 1. If I consider 1 minus x as z, so it will be minus. So therefore e to the power 1 minus x. That's the easiest way to go ahead. Otherwise you can go ahead and use the substitution as well. So therefore you will get it as 3 by 2 sorry, 3 by 2 inside the bracket with a minus sign, e to the power 1 minus x minus 1 by 2 e to the power x minus 1 with a limit 1 to 1 plus ln of root 3. That's it. Now see that we just already solved this integration and put all those limits and all that. Now our job is to put that appropriate values and get it done. So let's go ahead and substitute it in one line. So we can say that it is 1 by 2. If I put e to the power 1, so we'll get it as 0 minus e to the power 0. Then if I put 0, so we'll get it as minus e to the power minus 1 and plus e to the power 1, and that's it. And if I substitute that ln 3, like now we'll get that minus 3 by 2. So therefore you can take that minus out for better calculation, because every sign will be important. So if I take minus common, we'll get it as 3 by 2. We'll get it as e to the power of minus ln root 3 plus 1 by 2 e to the power ln root 3. That's it. And both are minus, so minus 3 by 2 and e to the power 0 minus 1 by 2 e to the power 0. That's it. Let's go ahead and calculate now. So therefore we'll get it as 1 by 2. E to the power 0 get cancelled, and we'll get it as minus 1 by e plus e to e. Okay, that's it. And minus we'll have it as 3 by 2. Okay, e to the power minus ln by 3, it will gives me that 1 by root 3 plus 1 by 2 and root 3 minus 3 by 2 minus 1 by 2, and that's it. So therefore we'll go ahead and see that we'll get it as 1 by 2 e minus 1 by e minus root 3 gets, so root 3 by 2 plus root 3 by 2, and we'll get it as 4 by 2. Okay, that's it. So therefore we'll say that it is 1 by 2 e minus 1 by e. If I now take that minus inside, we'll get that 2 minus root 3, and that's it. So therefore for this particular problem, option A is the correct answer, and that's it. Hope you understood the problem. Thank you.